Hi everyone, welcome to DOP 401, Simplifying Kubernetes Application Management with CDK8s. My name is Eli Polonsky, and I'm a software development engineer on the AWS CDK. Let's see what we have planned for today. Before we dive into CDK8s, I want to tell you a little bit about myself and my personal journey from the AWS CDK to CDK8s. We'll then see what CDK8s is and see a short demo. We'll see how you can integrate CDK8s with the AWS CDK to provide a complete and unified Kubernetes workflow, including both application and infrastructure management, also followed by a short demo. Finally, we'll wrap things up with an overview. So, a little bit about myself. I've been in the infrastructure world for quite a few years now. I've used the classic click-to-launch wizards, wrote long automation scripts in Python and Bash, and eventually landed on defining even longer orchestration templates using YAML. I've seen it both from a user perspective and as a vendor, where I developed several infrastructure definition languages that help my customers express their architecture in a clean and maintainable way. Unfortunately, every time I thought I nailed it, a different use case emerged that my language just wasn't designed for. As I added more and more capabilities, what started out as a simple configuration language had evolved into a full-blown programming language, with loops, conditionals, and references. This is me on an especially dark and frustrating day. It became evident that simple DSL-based configuration files are just not sufficient to describe modern cloud architectures. That's why I was so excited to discover and eventually join the AWS CDK. So, what is the AWS CDK and how is it related to CDK8s? The AWS CDK stands for the AWS Cloud Development Kit. It brings general-purpose programming languages, which we are familiar with from our application code, to the world of infrastructure provisioning. It lets us use the same language for both, benefit from the same tools, and easily create shareable abstractions with sane defaults. The AWS CDK currently supports Python, TypeScript, JavaScript, Java, C#, and Golang coming soon. In a nutshell, the AWS CDK lets you write code that describe your AWS resources. Here, I'm defining a VPC with just a single line of code. Under the hood, CDK will also define subnets, route tables, internet gateways, and all the necessary components that comprise a fully functional VPC. When I run CDK synth, a CloudFormation template is generated, which I can later use to provision the resources. The building blocks of CDK applications are called constructs, which represent some sort of composition. Constructs can be single or multiple AWS resources. They can be complete CloudFormation stacks, or even full-blown applications comprised of multiple stacks. Constructs are defined in code, just like regular classes. And as we've seen, they synthesize into CloudFormation templates. As a user, I'm able to treat my infrastructure definition as I would any normal software project. And as a vendor, I'm able to create abstractions and API that help my customers do the same. Soon after I joined, I started working on the EKS construct, which is similar to the VPC, but for provisioning EKS clusters. This meant I had to get very familiar with Kubernetes provisioning and application management. It didn't take long for me to feel that I was right back where I started. First, I was back to YAML. As we know, Kubernetes manifests are written in YAML. YAML is easy when you only have a few things, but gets harder to maintain as your application grows and requires describing more complex ideas. Since Kubernetes resources often reference each other, we commonly copy-paste the same value across the manifest. There's also no natural way of consuming other manifests. This promotes extensive copy-paste and makes updates complex and error-prone. YAML is also not configurable, which means that customizing it requires manual work or special tooling. This in turn makes it hard to share and results in a lot of duplicated work. Second, I began to experience something called high cognitive load. Cognitive load is the effort associated with learning and storing knowledge on a specific topic. When cognitive load becomes too high, we feel mentally exhausted, and our productivity drops. I was drowning in countless Chrome tabs, looking up spec definitions and examples to what I was trying to build. I also noticed that manifest authors are commonly exposed to the underlying mechanics of the resources they're trying to create, even though those mechanics are not always necessary to understand. Manifests are also data-driven, which is great for machines and can be easy for humans as well, but sometimes a more intent-based approach makes it easier to reason about. I could see the power of Kubernetes and its rich and extensible API, but I was a bit frustrated with the developer experience. It felt like CloudFormation templates all over again. Luckily, the team had already been down this road, and it was this road that led us to develop cdk8s. So, what is cdk8s? Well, this slide should look familiar by now. CDK for Kubernetes, or cdk8s, is an open-source, multi-language software development kit for defining and modeling Kubernetes applications. Now, I want to mention that cdk8s is not in any way tied to Amazon EKS. It generates pure Kubernetes manifests that can be deployed and applied to any cluster. cdk8s currently supports Python, JavaScript, TypeScript, Java, and C# and Golang are coming soon. In a nutshell, cdk8s lets you write code that defines your Kubernetes resources. Here, I'm defining a deployment with roughly 3 lines of code, specifying only the most critical information and letting cdk8s take care of the underlying mechanics. When I run cdk8s synth, a Kubernetes manifest is generated, which I can later use to apply the resources. So all we've talked about till now basically boils down to the following development workflow. On the right, we have our goal, provisioning Kubernetes resources. Let's see how we get there. We start with the cdk8s CLI and use it to create a cdk8s project in the language of our choice. You can also use other project generators or create it manual. This just comes with some convenient presets. We then start defining our application using the cdk8s API, creating constructs and charts. When we're satisfied, we synthesize the application to generate the Kubernetes manifest. And at this point, we leave the cdk8s world and enter a pure Kubernetes one. You can take the manifest and apply it however you like, whether it's issuing kubectl commands or utilizing GitOps tools such as Flux and Argo. Also, since this is just code, you can choose to publish your application to standard package managers for others to consume. The last thing I want to talk about before we see a demo is the notion of construct levels. The cdk8s consists of 3 different API levels, each building on top of the other. The first level, level 0, represents a generic Kubernetes API object. It contains only the common functionality such as API version, metadata, and kind. You can use it to define any object, but since it's not aware of the concrete type, it offers limited assistance and features. The next level, level 1, represents concrete API objects. It's fully auto-generated from the Kubernetes API specification and offers strongly typed classes for each of the Kubernetes resources. Level 2 APIs represent the same concrete objects, but are handcrafted to provide a simpler experience, implementing a lot of the underlying mechanics on the user's behalf. Okay, let's see how this all looks like. First, I need to install the cdk8s CLI using npm, and I've actually already done this, so I have the cdk8s command line available. I'm using TypeScript, so I'll also need to initialize a cdk8s TypeScript app, and I've done that as well. It generated a Node.js project for me, so let's open it up in code and see what it has. So there's the standard Node.js application files and the main.ts file. This is the entry point for the cdk8s application. It defines our chart and our app, and this is where we'll be adding resources to. Every cdk8s chart generates a manifest to a different file, and an app is composed out of multiple charts. Now, since we don't have any resources at the moment, we expect that if we synthesize the app right now, we'll have an empty manifest. So let's just make sure that this is the case. So to do that, I'm just going to run cdk8s synth. And you can see that it generated this YAML file here in the dist directory. And yeah, it's empty. So we're good. Let's start coding. So the application we'll build is a very simple Hello World Kubernetes deployment. And like I mentioned in the previous slide, there are 3 APIs that cdk8s offers to do that. There's the L0, the L1, and the L2. And we'll skip over the L0 and just go ahead and directly start with the L1. So to do that, we import it as k8s from the imports directory, which has this k8s file. If we look at it, we see that it's a pretty big file that contains the entire API spec or API, Kubernetes API, as strongly typed constructs. And this was auto-generated during the cdk8s init command. we can now use these constructs in our application to define the resources we need. So let's define a deployment. We do cdk8s cube deployment. We pass it a scope and an ID. And now we need to configure the spec. So because these are strongly typed and auto-generated from the schema, we have type assistance and IDE completion and all the nice things we normally have from strong typed languages. So you can see that there are two mandatory properties here, the selector and the template, and all the others are optional. There's also nice API documentation in line, courtesy of the API schema. All right, so let's start with the template. Now, I don't actually remember how to configure a template, so I'm going to rely heavily on this completion here. And here is my containers. So let's just define one container. Let's give it a name. And we'll use the Alpine image and configure a very simple command that just runs in an infinite loop and logs some messages. So we're going to do while true, do echo. Let's just also configure a date here. And hello, sleep for 2 seconds, and we're done. All right, now we also need to configure the selectors here. So let's configure a selector. And let's give it app. Okay, and now we're supposedly done. The compiler is happy, and we're also happy because we gave all the information we wanted to give. So let's just run cdk8s synth and see what the manifest looks like. All right, so now the manifest basically mirrors what we wrote in code, right? It's just the same configuration. We also see this metadata name here that was auto-generated by cdk8s. And this is nice because actually Kubernetes requires every API resource to have a name, and cdk8s does that for us. You can also access it programmatically if you need to from the name property, but we don't need it right now. All right, so let's just apply it and see what happens. So if we run kubectl apply, we get an error. And the error says that the metadata of the template doesn't match the selectors that we passed. And this is true because we need to actually configure the template with the correct metadata so that the deployment will select it. Now we can do it like this. And now the compiler is happy again, and we are happy. But it did feel a little too overly complicated. Like without prior knowledge of this whole selector mechanism, I had to try to deploy, get an error, understand what that error means, even though, strictly speaking, I don't really care about this. This kind of feels like it should be inferred or implemented for me. So this brings me to the third API that CDK8s offers, which is the L2s. And these APIs are meant to do exactly that. They're meant to offer a similar API, but with reduced complexity and reduced cognitive load. They don't require you to know every mechanical detail that's needed in order to configure those resources. So to use that, we're going to import the K plus package from the cdk8s plus module. Now, this is a separate module, and it comes pre-installed with the template, so you can just import it. And it's handcrafted constructs as opposed to the L1s which are generated. These are handcrafted by us, by the community, by anyone who cares to contribute. And let's see, they have the API is very similar and it offers a construct for every underlying Kubernetes resource. So let's try to do the same thing we did, but with these higher level APIs. So we do K plus deployment. Again, we give it the scope and the ID. And we configure the properties. And now if we look at the properties, we see it's a little bit different. There is no spec that needs to be configured, no selectors or anything. It just immediately offers the thing that is most important to you and the thing that you want to configure. So I'm just going to configure this container here again. I'm going to use Alpine. And notice that I don't even have to specify a name because a name is inferred by cdk8s. Okay, and the command I'm going to do is the same command, -c, and while true, do echo date, something like this. Hello, sleep, sleep for 2 seconds, and we're done. And now the compiler is happy. I didn't have to specify any selectors or metadata. So let's see what the output is. Okay, so now our manifest looks similar to what we saw before, but it also contains this automatic selector handling, right? There's a selector for the deployment, and the metadata of the template also matches that selector. And this is exactly what I want. Like, I just passed in the container information, and cdk8s Plus took care of all the underlying wiring and mechanics for me. Okay, so now I can apply this manifest. And let's see what we get. So let's take a look at the pods. It's still creating. Let's give it a few seconds. Okay, now it's running. And if we do logs, we should be able to see. Yeah, so here we go. There's a nice hello world logging container that we did in just basically one line of code. Okay, so the last thing I want to show you here is how CDK8s can integrate with custom resources. Custom resources are great for creating abstractions in Kubernetes. They are essentially also, they reduce complexity, they reduce cognitive load, and they're a great way to share abstractions. And CDK8s can actually import, similarly to how it does the L1s, it can import custom resource definitions so that you can use them as strongly typed classes in your code. So to do that, I'm just going to import, for example, this ECK Elasticsearch custom resource. And if I do that, then inside my imports directory, where we only had k8s prior, we now have all the custom resource definitions of the Elasticsearch ECK CRD. And you can just create those constructs and initialize them as easily as we did with the kube deployment. Okay, let's move on. Soon after we launched CDK8s, we started getting requests from our users that wanted to combine both CDK8s and the AWS CDK in the same application. This made perfect sense, because real-world applications typically combine elements from these two domains. And actually, the team was already working on an internal application that could benefit from this integration as well. Let's take a look at it. So our application had a VPC and an EKS cluster. We also needed an SQS queue that would subscribe to an SNS topic, and we used Amazon Elasticsearch Service to index data that we read from the queue. This can all be easily provisioned and managed using the AWS CDK. Inside the EKS cluster, we had a simple deployment with one pod that contained our runtime code. This can also be easily created with CDK8s. But we had two problems. One was that our pod needed access both to the SQS queue and to the Elasticsearch service. There was no easy way to pass this information, so we had to resort to custom scripts or convention-based config maps. The second problem was that our deployment process was complex, because it involved running two separate build and deploy workflows in two different and decoupled repositories and codebases. What we really wanted was to treat this entire architecture as a single deployable unit. What we wanted was this: for the AWS CDK to take control and provision and deploy everything. We started on enabling this, and I want to show you how that looks like. Before we get started, let me just kick off the deployment here, because it's going to take a few minutes, and then we can look at the code. Okay, so our goal is to include AWS resources into our CDK8s application, because the CDK8s deployment, the Kubernetes deployment, actually needs AWS resource for its functionality. So in our case, we need an SQS queue to read messages from, and we need an Elasticsearch domain to index those messages to. So to do that, I just import the relevant AWS CDK modules, and I use them as if it was a regular AWS CDK application. And actually, for all intents and purposes, it now is. So what I did was extend my cdk8s chart by having it accept these two properties here. So I created an interface that declares the queue and the domain, and now I can pass in those properties to my chart. Inside the chart, I use the properties to configure two environment variables. One is the queue name, and one is the domain endpoint. And I'm just using the k+.envvalue API, and I can pass in CDK tokens to it as if they were regular properties available at synth time. And this is just the normal kind of CDK experience. I also changed the command here so that we can look at those values when we query for the logs. So I changed it to reading from queue name and indexing to domain endpoint. And now these are just normal environment variables, which I can use however I like inside my container. The next thing I did was create a CDK stack, because all the AWS resources will be provisioned inside that stack. And inside it, I have the SQS queue, I have the SNS topic, I'm subscribing the queue to the topic, I'm creating an EKS cluster, which will host our manifest, as opposed to a local kind deployment I had before. Now we'll be using EKS. I'm also configuring the root account as a master role for the cluster, because this is going to enable us to see the workloads from the AWS console. I'm also creating the Elasticsearch domain here. And now I can instantiate the chart and just pass in the domain and the queue as properties, which will later be used like we saw here. Finally, I'm using the AWS CDK EKS module integration with the CDK8s. So using add CDK8s chart, I can pass in a CDK8s chart, and internally, the EKS module will synthesize that chart and embed the manifest into the CDK output or to the CloudFormation template. And actually, let's see how this looks like. So if we look at the CDK output here, and specifically the CloudFormation template, we'll see here this manifest property. And this actually is the same manifest that we saw before. It's not as pretty as this one with this YAML formatting, but it's actually the same, apart from the changed command, of course. And now we also have these magical CDK tokens that will fetch the runtime information that we need during the deployment. Okay, one last thing here is that now when I instantiate the app, instead of instantiating a CDK app, I'm actually creating a CDK app. And instead of adding a CDK chart to it, I'm adding a CDK stack. And now all I need to do is synth the CDK application. And this is why all I had to do was run CDK deploy, because actually this is now just a CDK application that uses CDK as an external third-party model for Kubernetes manifest authoring. Okay, so the deployment's finished. We now need to run this command to configure our local kubectl to connect to the EKS cluster. So let's just run this. And before we look at the logs, let's see how the AWS console looks like. So if we look at this cluster here, we can see that, here is my deployment. And we can see that there is one pod which is running, created 2 minutes ago. And it has one container called main, which is the implicit name that CDK8s Plus assigned. Here is the command that we configured. And here you can actually see the properties or the environment variables and their concrete value after the deployment resolution. Okay, so now all we need to do is take a look at the pods here, get the pod name, and query for the logs. Yeah, and we can see that just like before, we have a message every 2 seconds. You see it's running right now. And it says reading from CDK8s reinvent. This is the auto-generated name of the queue that CDK8s provisioned. And it's indexing to the Elasticsearch domain, again, that the CDK provisioned for me. Cool. All right, so that's what I wanted to show you. And now we can start wrapping up. Okay, to wrap things up, let's quickly go over what we've talked about today. First, we talked about the AWS CDK, and we saw how you can use general-purpose programming languages to write code that synthesizes into CloudFormation templates. We then spoke about CDK8s and saw that you can do the exact same thing for Kubernetes, writing code that generates Kubernetes manifests. We saw how this approach opens the door for combining these two domains in a very natural way. We used CDK8s to create our Kubernetes application, and we used the AWS CDK to provision an EKS cluster and deploy the application to. Now again, I want to reiterate, CDK8s is not tied to Amazon EKS. It generates pure Kubernetes manifests. And finally, I think we've seen that infrastructure is indeed code. Over the past few years, the distinction between application code and infrastructure has become more and more vague. Application developers want to utilize infrastructure capabilities, which are becoming so extensive that they require more flexible and maintainable approaches to define it. I hope this session gave you a glimpse into how these tools such as AWS CDK and CDK8s can help you simplify your interaction with these awesome orchestration platforms. Before we go, here are a few resources that will help you get started. First, we have a dedicated CDK8s website that has a bunch of material to learn more about CDK8s. There's documentation, examples, and links to all our other resources. cdk.dev is a vibrant, all-around CDK community, where you'll find Slack channels for all the CDKs out there, including CDK for Kubernetes. If you want to learn more about the integration of CDK8s and AWS CDK, visit our GitHub repository. And of course, CDK8s is open source and contributions are more than welcome. Thanks for tuning in. Bye-bye.